Hey, good morning, guys. I'm going to continue today with our chapter 11 notes, just working in the second section here in chapter 11, 11.2. I got the PowerPoint up. I got our notes up. I'll be referring to both. So just do your best to kind of follow along. Pause the video as you need, but both have been posted now inside Classroom, so you should have them to kind of look at as we're going through this. All right. So to highlight chi-square test for homogeneity again, just want to make sure we're okay with this. Our HO and our HA, right? There's no difference in the distribution of a categorical variable for several populations or treatments. So chi-square test for homogeneity, we have multiple populations or treatments. We have one variable, okay? The example in our notes that we'll start with today is this one that's called the colorful candy. And the idea here is a statistics student decided to investigate other ways to influence a person's behavior as far as what does background. So there was that example, does background music influence what customers buy? So they kind of ran with that here. There's 60 volunteers. She's randomly assigning 20, all right, to the red survey, the blue survey, and then the control one. The first three questions on each survey were all the same, but the fourth and fifth were a little different. For example, the fourth question on the red survey was, when you think of the color red, what do you think about? On the blue, the question was just simply replaced with red. And on the control, the questions were not about color. All right, and as a reward, the student let each volunteer choose what type of candy they wanted. There were some in red wrappers or blue wrappers, and here was the results. Okay, so if a student took the red survey, they chose the red candy 13 out of 20 times, compared to the 7 times they chose the blue candy. Okay, and here's the differences between the types of surveys: the red, the blue, and the control. We're asked to compare the distributions of color choice. All right. Compare the distributions just kind of means like find the percentages. If you want to do it graphically, if you want to write a couple sentences about it, that's all that means. Okay. When you see, does the data provide convincing evidence? Now we have to run a significance test. Okay. So the conditional distributions were found. Okay. They were graphed here. A couple comments here in A. As shown in the bar graph, people with the red survey choose red candies more often, and people with the blue surveys choose blue candies more often. Okay. So again, just brief comments once you find the conditional distributions. What we have to really put our focus on is the significance test here. All right. Check out the HO and the HA, right? Very similar to what's over here in your PowerPoints, just in context. So there's no difference in the true distribution of color choice for people who get the red survey, the blue survey, or the color or the control survey. You can just abbreviate it for now, but we talked about this yesterday. We had a Zoom meeting. It was good to see everybody. I don't know how much stat we got done, but it was good to kind of catch up and joke around a little bit. We talked about in there that the AP test has changed. College Board has kind of revisited some things here, and they said that it's only going to be a 45-minute test. It's going to be all free response questions. So just start, really kind of getting in the habit of answering questions as though you would plan to answer them on the AP test. All right. We'll talk more about that later, though. So back to this problem. The conditions: random, 10%, large counts. All right. Our expected counts were found here. I showed you how to do that yesterday or a couple days ago in the calculator. Hopefully we're confident with that, guys. It's going to save us a lot of time. We got the chi-square test statistic. Remember, to get your p-value, the calculator would give that to you, but if you had to find it another way, degrees of freedom right now is the number of rows minus 1 times the number of columns minus 1. Okay? And we can make our conclusion here. It's important that every time we see that when we reject the HO, we could be asked for that follow-up analysis. All right, so anytime that you find convincing evidence in favor of your HA, you might have to do a little follow-up to just kind of examine the differences in detail, meaning like which ones contributed to that chi-squared statistic the most. Okay. So here's a check your understanding, which you guys could do. Let's just kind of continue with the notes here. All right, now the last type of chi-square test, right? The first one we did was chi-square test for goodness of fit, chi-square test for homogeneity, and now we're going to look at what's called a chi-square test of independence. Okay, so I think as you go through these, it would be great to kind of like associate them with a particular example. This way you can kind of decipher which one should you just be given a problem like this, and okay, now you have to choose, right? So think of the candies, all right, for goodness of fit. Think about some of the examples we just did together here as far as homogeneity goes, where we had multiple populations or multiple treatments, but we only had one variable. All right. Here, with the question that we did chapters ago, we're going to have multiple variables, but we're going to have one population. Okay. So when a single random variable of individuals is chosen from a single population, and then classified based on two categorical variables. All right, we're going to analyze the relationship between those variables, between the finger length and gender here, making this a chi-square test for independence. All right. Just a couple questions here. Is this observational or an experiment? If you forget this question, it's they sampled over 450 U.S. high school students, completed a survey here. They were asked gender, and they were asked which finger was longer on their left hand. So this is an observational study, okay? Nothing was randomly assigned here. The students were just asked to take this, okay, and answer these couple questions here. Make a well-labeled bar graph. Describe what you see. So again, this idea of making a bar graph, you can make it of your choice, whether it's side by side, segmented, okay? But you just want to make sure you see the differences between males and females and their finger length, all right? And then be prepared to write a couple sentences as you see up here. All right, so here's the idea. Is there an association in the sample evidence of an association between these variables and the entire population? All right. Or could this just arise from a lack of random sampling? So here's the null hypothesis. There is no association between two categorical variables in the population of interest. All right. The HA would just be that there is an association. So the null hypothesis, there is no association. The HA is that there is. So let's explore the same survey. All right. Kind of see the expected counts here. All right. Which can be found multiple ways. You know, they could be found with the percentages that you found. They could still be done with doing the row total times the column total divided by the table total. They could also be found just by making the matrix in the calculator, which is the route that I would go. All right, we would check our conditions here. And if you look over at the PowerPoints, I kind of outline them for you here. Right? You have your random when sampling without replacement. Make sure it's less than 10% of the population. All expected counts need to be greater than 5. All right. Here's the wording again for the HO. There is no association between two categorical variables. The HA is that there is. Everything else stays the same pretty much, right? Our expected counts, we'll find that in the calculator. We'll let the calculator do the work for the chi-squared statistic. We'll ultimately make the same conclusion. Degrees of freedom is still rows -1, columns -1. All right. Chi-squared is still a right skewed, right? So here would be our example here, right? There's no association between gender and relative finger length in the population of U.S. high school students who filled out the census at school survey. So it was one population of students, but it was multiple variables, gender and relative finger length, okay? Our plan is laid out, and we kind of want to make sure that we do that, guys. Think about the chapters that we've done significance testing, right? There's a whole bunch of tests. There's one prop Z tests. There's 2 sample T intervals or 2 sample T tests. So we want to make sure that we identify in our plan which type of test we're doing, okay? So in this case, once these conditions are met, we're going to carry out the chi-squared test for independence, all right? Chi-squared number was found, degrees of freedom listed, p-value listed, okay? Conclusion was made. So with such a small p-value here, approximately 0, we clearly reject the HO. We have convincing evidence that there is an association between gender and relative finger length for this population of U.S. high school students. All right. So there's similar examples on both sides of your screen right now, on the PowerPoint as well as in the notes. Okay. Right now, just the focus would be, okay, how do we decipher which one to use? Okay, that's what I kind of mentioned earlier as far as trying to attach an example that you feel comfortable and confident with to that type of test. This way you can kind of go back and compare as you're thinking about it. Right? So goodness of fit, one variable, one population. So one bag of M&Ms, the distribution of colors. Homogeneity, one variable in two or more populations. All right? Independence, two variables in one population. All right, so it's important to really take a look at these differences here. Okay. All right, so I like this example because it gives some data here and it asks us a couple questions, and we can kind of just talk about how we would change the type of test that we would need to use. All right. So again, the question here would be, suppose that you decide to analyze these data using the chi-square test. However, we don't have information about how this data was really collected. All right. So because of that, we don't really know which one's appropriate. Question A says, explain how you know that the test for goodness of fit is not appropriate by analyzing these data. So that's the obvious one. Why is this not appropriate? Well, we either have one of two things here, right? We either have there's two variables, okay, or there's two or more populations, right? We have these different groups here and here, so it's definitely not goodness of fit, okay? To make it a chi-square test for homogeneity, we would need to take 6 independent random samples, one from each category, then ask every person whether or not they use online social networks. All right? Or we would take 2 independent random samples, one of online social networks, one does not use it, and then ask them which age group they fall into. Okay? So for chi-square test of homogeneity, we need to somehow come up with multiple populations or multiple samples. So we could ask groups of 18 to 24, 25 to 34-year-olds, 55 to 64-year-olds, so multiple populations, and then ask them the question of, okay, do you use social networks or do you not? With the chi-square test for independence, we would need to take one random sample from this population, and we would ask every member 2 questions. We'd ask them about their age. We would ask them about their use of online social networking. Okay, so that's the difference. The difference is the number of variables and the amount of populations. Hey, Liv. You want to learn some stat? Come here. Yeah. I don't know if you guys can make out baby language, but that's what I deal with. All right. So I like that example just because it kind of deciphers it kind of goes through the different types of tests. As does in the PowerPoint here, guys. It's going to do the same thing. So, definitely read through this stuff. I don't want to repeat myself again, but just kind of read through it as you can. It should definitely help as far as choosing the right type of test. All right. And when you're all done, you just want to make sure that you are comfortable comparing the conditional distributions, that you can state the hypotheses, that you can figure out the expected counts and the chi-squared number, which you can definitely do on the calculator. Make sure you know how to do that. All right. You want to understand the difference between these 3 types of tests. Okay. Mainly in this particular section when the focus was on homogeneity and independence. But definitely want to, tell the difference between chi-square goodness of fit as well. All right. So what I'm going to ask you to do today is to watch this video and then to also do the 11.2 worksheet. All right. I'll put that assignment in Classroom. Guys, try to enjoy the day today. We'll definitely set up another Zoom just to kind of, see each other, try to bring some normalcy, back to how we're doing things here. But hope everybody's doing well, and I'll talk to you soon.